It's Mr. Lum, and we're going to be doing some more Chemistry 11, and this time we're going to be talking about what is the mole. And the mole is a chemistry number that kind of like signifies like how many particles of a substance there are in something. So I always like to tell people like the mole is kind of like using the term a dozen. When we say like a dozen cookies or a dozen bagels or something like that, or a dozen eggs, it means 12 of this. Now, 12 eggs might not weigh the same amount as 12 bagels, but we know that a dozen means 12. And a mole in chemistry is kind of like a dozen. A mole means 6.02 times 10 to the 23 particles. Okay, so just like a dozen means 12, a mole means 6.02 times 10 to the 23, which is a very, very, very big number. But particles are really, really small. So now, 1 mole of carbon means you have 6.02 times 10 to the 23 particles of carbon. 1 mole of magnesium means you have 6.02 times 10 to the 23 particles of magnesium. They don't weigh the same amount. Carbon, if you had a mole of carbon, it'll weigh 12 grams. If you have a mole of magnesium, it'll weigh 24.3 grams. Okay. They also might occupy a different volume. Carbon particles might be a different size than magnesium particles, so they might operate a different volume. They might also have like, well, in this case, they do definitely have a different mass, but they will have the same number of atoms that are there. So what we call this is we can call this the molar mass, the mass of 1 mole of particles. So even though carbon has 6.02 times 10 to the 23, the molar mass of it is 12, and the molar mass of magnesium, or the mass of 6.02 times 10 to the 23 particles of magnesium, is 24.3. Okay, and these numbers can be found, this 24.3 and this 12 can be found on your periodic table. Those will also be called atomic masses on your periodic table. So here is your periodic table, and what we can see here is that just like before, we said that the molar mass of carbon, or the atomic mass of carbon, is 12. Okay, so the atomic mass is 12. That means 1 mole of carbon weighs 12 grams, so we call it's the molar mass. And we already talked about magnesium, and if we talk about like sodium is like 23, so if you add 1 mole of sodium, or 6.02 times 10 to the 23 particles of sodium, it will weigh 23 grams. Now what happens if you had something like this, carbon monoxide? So the formula for carbon monoxide is CO. Okay, there's 1 carbon and there's 1 oxygen there. So 1 carbon has an atomic mass of 12. Okay, 1 oxygen has an atomic mass of 16. Okay, so what is the molar mass of carbon monoxide? Well, it's going to be 28. Okay, so again, if I drew out 6.02 times 10 to the 23 carbons, I'd be drawing a lot of carbons like this. Okay, here's 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and I'd draw them out till I got to 6.02 times 10 to the 23. If I drew 1 mole of carbon monoxide, it would look like this. That's also 5 carbon monoxides. Okay, and so you have to add the masses of the carbon and the oxygen, because that now counts as just one of these. And so the mass of 1 mole of carbon monoxide would be 28 grams. You add up everything that's in there. So let's talk about like when you get a little bit of a larger compound now. So right here, this first one right here, I have sodium chromate, okay, Na2CrO4. Now here, in this one right here, we have 2 sodium. So we have 2 sodium, and I wrote 2 sodiums. We have 1 chromium like that, and then we have 4 oxygens, okay? So when you want to find the atomic mass of sodium chromate, well, we have to go 2 sodiums, and so each sodium is 23, so 2 times 23 is 46. We have 1 chromium, which is 52, and then we have 4 oxygens, so that's going to be 64. Okay, and so what we see is this is the molar mass of sodium chromate is 46 plus 52 plus 64, and that equals 162. Okay, now in terms of significant figures, I want you to think of it as this, is that you have 2 sodium. So you could be going like this, 23.0, because that's what sodium is 23.0, plus you're adding another sodium, which is 23.0 again, and then you're adding 52.0, and then you're adding a 16.0, 16.0, 16.0, and a 16.0. Now, in terms of sig figs, you have 1 decimal place for everything right here, and so this is what it's coming out to be. So even though like here everything is 3 sig figs, your final answer is actually going to be 4 sig figs. Okay. So another way you can do it is that if you're calculating molar mass using this periodic table that always is giving molar masses or atomic masses with 1 decimal place, that since you're adding it always together, your answer will always have 1 decimal place. If you're using a different periodic table that might have like 2 or 3 decimal places, then the sig figs could be changing. But for this periodic table that we use, it'll just be 1 decimal place. Okay, so you can put the video on pause if you want and calculate the molar mass of this thing right here. First, you can name it and then calculate the molar mass. But if you've done that now, I'm going to name it first. So this is aluminum oxide. Aluminum is not multivalent, so it does not get a Roman numeral or anything like that. So it's aluminum oxide, and then we have 3 water, so that's called trihydrate, or aluminum oxide trihydrate. So same thing, we're going to kind of calculate all of this stuff out. And I'm going to do it, so in this first question, I kind of did it more of a formal way, making a table and all that kind of stuff. I'm going to kind of like, this is the way that I kind of do it when I'm doing a short kind of hand way, is that I go, okay, my aluminum is 27. I have 2 of them, and so 27 plus 27 is going to be 54. So I have 54. That's not the best 5. So we'll do 54 like that. Okay. Now my oxygen is 16. So 16 and 16 is 32. Plus another 16 is 48. So I'm going to go plus 48.0. Okay. Now I have 3 H2Os. Okay, and so 1 O is 16, and 2 hydrogens is, well, hydrogen is 1, so this is going to be 2 of them is 2.0. Okay, so 1 H2O is 18. Okay, now you have 3 H2O. So you have 18 plus 18 plus 18. Okay? And now I just add all of those things up, and that's typically how I calculate my molar masses. So I go 54 plus 48 plus 18, and that's 3 times, and so I get a molar mass of 156.0 sig figs. Okay, now what does that mean? What does this 156 mean? And I kind of messed it up on the first one as well. It means how many grams is in 1 mole. Okay, so if I had 156 grams of aluminum oxide trihydrate, then I would have 6.02 times 10 to the 23 particles of aluminum oxide trihydrate if I had 156 grams of it. And for this other one right here, if I had 162 grams of sodium chromate, I would have 1 mole of it, or I would have 6.02 times 10 to the 23 particles of sodium chromate if I had 162 grams. Okay, so this is just the basics of how to calculate molar mass and what is a mole, and we're going to go a lot deeper dive into moles, but these are the basics of it.